Hi everybody, Mrs. Mancuso here, ready to do some more redox with you. So remember, redox reactions were the reactions that we were doing last week where something gets reduced and something gets oxidized. So if I give you an example, Mg plus AlCl3 would form. Okay, so Mg is a plus 2 and Cl is a minus 1, so that would give me MgCl2, and then aluminum would get knocked out, so it would be by itself. So the first thing I got to do is go ahead and balance it. So if I have 2 Cl's on this side and 3 Cl's on this side, I'm going to have to get to 6 Cl's. So I put a 2 in front of that and a 3 in front of this. And that gives me 3 magnesiums and 2 aluminums. And then in order to figure out if it's a redox reaction, remember I have to be gaining and losing electrons. So in order to figure out if something has gained electrons and something has lost electrons, I have to put everyone's oxidation states on top of them. Magnesium is alone, which means it's not gaining or losing electrons, so it's at 0. Aluminum, I can crisscross this 3 right back up there, and I notice on the periodic table that aluminum's oxidation state is most likely a plus 3, and that's why the 3 crossed down. And Cl is a minus 1, which is why a 1 crossed down right here. And aluminum is alone. And then oxidized and reduced. So remember, I had the little phrase oil rig. The oil goes up out of the earth and the rig goes down. So let's talk about what that means again. Oxidation is losing electrons. That means when I rate a half reaction, my electrons are going to be way over here. And then reduction is gaining electrons, which means I need to add the electrons before the arrow. And this arrow up means that the oxidation number goes up, and this down means the oxidation number goes down. So I like to say the rig goes down into the earth and the oil comes up out of the earth, and oxidation is losing, reduction is gaining. All right, so let's look at whose charges went up, Mg. So I write it just as it is before the arrow, 3 mgs. I don't have to put a 0 there, but if you like to, go ahead. After the arrow, it's 3 mgs at plus 2. Now I got to figure out how many electrons I have lost. So I'm going to just move that little plus sign over a little bit so I have room. Okay, the way that you figure out, it's changing from 0 to plus 2. So that's a change of 2. Times I have 3 atoms. 2 times 3, 6 electrons are lost in this oxidation. And then for the reduction, who is going down? So 2 ALs at plus 3 go down to 2 ALs. So they're going down by 3 because it's going from a 3 down to a 0 times 2 atoms, so 6 electrons. And I always want to make sure the number of electrons lost is equal to the number of electrons gained. And so that's how you write out your half reaction. So I'm going to do some more with you. So let's say I have HCl, hydrochloric acid, and I add, let's say zinc. The zinc is now going to go with the Cl, and zinc only has one oxidation number. It's plus 2. Cl is a minus 1. I crisscross, and I get ZnCl2. And then hydrogen is going to be all by itself, but I know that's one of the diatomics, so I have to put a 2 on there. Okay, I balance it by putting a 2 here. You're a plus 1, you're a minus 1, you're a 0, and you're a 0. So oxidation, reduction. To write the half reactions, first I see who's going up, that's zinc. So Zn becomes Zn plus 2 plus, and now I figure out how many electrons it would lose. It changed charge by 2 times 1 atom. 2 times 1 is 2 electrons. And then what gets reduced? What goes down? The 2 H pluses go to a 0. So 2 H's at plus 1. I'm going to add the electrons before the arrow, and I'm going to form just H2. So it changes charge by 1, but there's 2 atoms. So 1 times 2, 2 electrons. You'll also notice when you do this, everything should balance out. So if I have 2 plus 1s, that's a plus 2. And I have 2 negatives, so that's a minus 2. So it equals 0, and this has 0 charge on it. And 2 electrons gained equals the 2 electrons lost. Everything should balance out. Probably why I like doing these so much. All right, let's have CuO plus Al. So oxygen I know is a -2, and it didn't crisscross down here, which means if it knocked itself out, like if it canceled, this must have been a +2. So now I'm going to have Al, which I know is a +3, go with oxygen, which I know is a -2. I crisscross the 2 here and the 3 here, and now copper is all by itself. To balance it, I would need 3 of these to give me 3 O's, and that would give me 3 Cu's, and I would need 2 Als. You get a 0 on top, you get a 0 on top. All right, oxidation, reduction. Who's going up? Al. So 2 Als become Al2 with a +3 charge, plus electrons. All right, it changes by 3 because it's going from a 0 to a +3 times 2 atoms. 3 times 2, 6 electrons. Reduction, the one that's going down. So Cu, 3 Cu's at +2 plus electrons makes 3 Cu's. The charge is changing from a 2 to a 0, so that's a change of 2 times 3 atoms, 2 times 3, 6 electrons, and these balance. Okay, so with this one, I'm going to show you the next step. The next step is to write a balanced skeleton reaction. Balanced skeleton reaction. So a balanced skeleton is like bare bones. Skeleton is bare bones. So all you do is you put these two together, and like oxygen was unaffected, so I'm going to leave it out. So I had 2 Als before the arrow. I had 3 Cu's at +2 before the arrow. And then the electrons on either side are going to cancel out. And then after the arrow, I had Al2 with a +3, +3 Cu's. So that is my balanced skeleton reaction. I'll go back and I'll do it for this one too. So for this one, I have zinc before the arrow. I have 2 H's at +1 before the arrow. The electrons are going to cancel themselves out. After the arrow, I have a Zn, and I have an H2. Oh, and my Zn has a +2 charge on it. All right, I want you to notice that the charges are the same on the two sides. So this is a 0 because it has no charge, plus 2 plus 1s is a 2, equals Zn +2, so that's a 2, plus 0. So both sides are +2. And if I do that with the one that I just did, if I go back to this one, this is a 0. 3 plus 2's is a +6. 2 plus 3's is a +6. And this one is at 0. So it should all balance out. Again, one other reason why I really like it, everything balances. If I go back to the first question that we did and I do my balanced skeleton reaction, I have 3 Mg's before the arrow and I have 2 Al plus 3's before the arrow. After the arrow, I have 3 Mg's plus 2 and 2 Als. If I look at the charges, you're a 0. 2 plus 3's is a +6. And that equals 3 plus 2's is a +6. And this is 0. So it all works out. It all balances out. I just want you to get really good at writing half reactions and being able to write the balanced skeleton reaction from it. All right, so if you have any questions, let me know. Work on the practice sheet. I want you to draw right on the practice sheet. So when you are in Word, you should be able to go to the top bar and it says review, and then it says pens. And so if you click pens, you should be able to write with a stylus or your finger right on your computer. All right, happy redox reactioning.